So today's class discussion is really, trying to put tie a bow around our conversations involving the mechanical systems and energy code compliance. Um, and actually, that's not even the right. Am I got the right presentation up? I do. Why is the title slide not right? Let's do this. Energy code compliance. Let's get the right title on the screen. That'll be a start for us, right? Wow, today's gonna be one of those days, I think. So today, again, we're tying a bow around this conversation about mechanical systems. Wow. And so we're going to really drive into this idea of the inspection process. We talked about plan review. We've talked about mechanical design as a part of the energy code process. But now let's really focus more in on that inspection process. Now, if for some reason you do have questions, feel free to reach out to our website there, the Texas Energy Code Support Program for Xcel Energy. You'll be able to find different videos, resources, technical resources, documents. There, we are updating it to make sure, and I'll have to probably resend this uh, handout back out to everybody. For those of you that are interested in the handout, ignore the first part there, the title. But I'll throw those in the slides so that you have those for your use. Maybe if you want to pay attention throughout the class today. But if you've listened to any class I've taught, I've always hint off or start off on this belief that if we understand the why behind a code, behind a process, then we can better figure out the how we accomplish it. And I think that's a general way to look at, for me, most of what we do in code compliance and building inspections, the whole process. And so when we start to think about, excuse me, when we start to think about the purpose behind the code, whether we're looking at the building code or the residential code, the purpose is to provide some minimum expectation about what it would be for what it takes for a building to be safe and habitable, to be structurally sound, to consider energy conservation and other things like light, ventilation, sanitation, means of egress. All of those concepts pull together to build to determine what is a minimum expectation for construction. When we look at that in the context of our relationship to the mechanical code is all about the control of our design, construction, installation to evaluate the effective operation and use of the mechanical equipment. Right, so we're looking at how we build a building that's able to control the mechanical systems, and that builds on this concept, or is similarly reflected in our expectations associated with the energy code. Whether we're looking at it from commercial or residential, the energy code is looking at how we effectively use and conserve energy over the useful life of a building, right? It looks at different innovative or flexible ways to do that. And so there's a variety of different resources that or conversations that kind of intertwine together when we think about how do we inspect a building for energy code compliance. And one thing we've talked about before is that that code compliance and project success really begin on paper, right? It takes plan review and proper plan review to kind of build what is a sound methodology for inspecting a building. But energy code compliance requires inspections, right? Our plans examiners aren't the ones who are sitting at the desk. Our designers aren't the ones who are going out in the field and installing, right? They're setting up the groundwork. They're giving us the details. But we really have to get it in the field in order to understand and to really see how these buildings are being installed or being constructed. And the IBC and the IRC both provide guidance on what types of inspections are expected or provided to verify these systems. Now, when we think about the energy code, there are what I identify as 4 basic pillars of energy code compliance, right? There's the building thermal envelope, which is is that series of materials that separate the exterior environment from the interior environment. There's the air barrier, which assists in the control of our conditioned spaces of our, so we can isolate interior spaces, from exterior spaces. So it works in tandem with that building thermal envelope. And then there's the mechanical systems and the power and lighting considerations. So since today's conversation is more on the mechanical systems, it really is kind of a culmination of the previous trainings that we've had regarding this conversation, this system, right? If you remember 2 weeks ago or a couple weeks ago, we talked about mechanical design, then we talked about mechanical plan review last week. Now we're building on that to kind of see what did we do for inspections. Now, we know in residential and in commercial compliance, there are a lot of provisions of the energy code that address mechanical systems. And part of that is because we understand that no matter what we do in the envelope, right? If you look at code development, and, I participate, I participate in a lot of code development conversations. And you look at where the energy code is and is going. There is a place where there's a time, and I think we're in many versions, the 24, 21 energy codes are the ones that kind of get to that place of there's not much more you can do with the wall envelope, right? If we keep going with the, add more insulation. I was in a meeting earlier this week where the builder was saying, well, hey, why don't we just go ahead and the way I'm seeing this, the only way forward is to make it an R90 ceiling and an R60 wall. And then we're gonna have a 14-inch that they were proposing a 14-inch wall. And my response was, are you kidding me? That doesn't do anything. If you had a 14-inch wall, you're not going to save any more energy than if you have a 2x4 wall, 2x6 wall, right? Because it's not the insulation that saves energy, right? The insulation is just one piece of the overall project. So when we think about that, well, what really spends energy, what really utilizes energy is our mechanical systems, right? A little bit of the power and lighting. One of the things we talk about, I had this conversation this week. When we look at what the code actually says, the energy code, especially when we think about residential, so that's the main topic of our conversation here. When we think about the residential code, all it does, all the energies, the power side says, which we'll get into this further later, is really how much lighting do we use. It doesn't even get into, how many TVs or laptops or, PlayStations or radios or using the lights, right? Which is not a huge user of energy. The main user of energy in our building systems is going to be the mechanical system. And so when we talk about the proper design, we talk about proper plan review, we really are building or setting ourselves up for then the proper installation and inspection, right? That's where we use energy, is in the installation and is in the type of mechanical systems we design. And so that's why we see a lot of these sections coming up in that conversation. So like I said, plan review is a critical component. And then from that, we can get into this idea of field inspections. Now, if you remember, for those of you that were with us when we did the in-person training a couple weeks ago, we provided a guide to field inspection, field guide. And so if you do have comments, obviously let us know. I've thrown into the chat a breakdown of the mechanical section of those field guide notes. So if you do have questions, feel free to reach out, let us know. But I think when we start talking about, the field guide that we created was really something that when I looked at it and I use it as a way to really educate my my contractors on what I'm expecting, right? I can work with my supervisors and my project leads. Those are people that understand at some point what we're trying to accomplish, right? We're trying to build a building that's going to be effective, that's going to work, right? And so I typically, as an inspector, would use this page here, right? The mechanical field guide. But what I want to do And then I would use these other pages as the information I would give to the contractor and say, hey, here's something for you to give to people, to give to the new guy to explain what we're looking for and why we're looking for it when it comes to things like mechanical heating or water heating, or heating cooling systems, or water heating, or even if you have a pool. Why are we looking at it? Gives them those code references, give a little information about what we're looking for. Now, I'll make this comment to you guys again. If for some reason you read these and you're like, hey, I think we should say this a little different, or what about this? Reach out to me, let me know. Let's make this a better tool that gets used by jurisdictions, and not just something that sits on a website somewhere, right? But ultimately, the goal is that we're trying to find out, how do we marry the concepts of energy code compliance and mechanical plan review in the same process? And I don't think that's a difficult thing to do, in my opinion. And so let's take a look at what we've got here. Now, when I start a project, again, I understand, when I would do it in an inspection, I always started off with this idea that, what is my compliance path, right? I know it's something that just came out in the 21, but when I was doing inspections under the older codes, again, those were concepts. It's like, okay, how are we doing this? Am I looking for, and even when you think about it in residential construction, right? Is this a prescriptively built home, or is this a designed home, right? Same concept when we get to the energy code. Is this a prescriptively built home, meaning that we're following the tables provided in sections 401 through 404, right? All of the requirements in the mechanical code, of the mechanical section, all of the installation expectations we see in the code? Or is this one of those performance-based designs where we're looking at how much does it cost? That's what the total building performance is looking for. How much does it cost to run this house for 1 year, right? Versus the energy rating index, which says, well, if we were going to give it a grade on a scale of 1 to 100, with 100 being horrible, with being 2006 version code, and 0 being, no energy ever, where does this house rate, right? What grade would we give it? That's really what we're looking for in an ERI, right? It's not so much how much it costs, but how well it does. And this is all about how much it costs. And so again, it's the same concept we see in traditional plan review, or traditional construction that we see in energy. What is my compliance path? Am I following a table? Am I looking at a code section saying, hey, how does this match? Or am I looking at a design where we're going to go over the line, go over the code minimum, but I still have to meet this because that's what's required to get me to full compliance. So again, that's the first thing I always think of as an inspector. How flexible am I going to be when it comes to this design? What am I expecting to see when I walk on site? And when I think about what else is in those construction drawings, the code tells us that at least 4 of the 9 things listed to be listed on the construction documents relate directly to mechanical systems, right? It's the design criteria, showing me that you're in the right ballpark, right? Showing me what kind of equipment you're going to have, what size equipment, what efficiency that equipment's going to be, what are the controls associated with that equipment, and how are we going to distribute, right? How are we going to duct this system out? And so when we talked about this last week during plan review, we talked about those expectations. Okay. No, Guadalupe, I see you sign in as you. Sorry. So when we start thinking about, like we talked about last week with plan review, there are certain types of submissions that we see, whether they're commercial or residential, and what those expectations are going to be, right? We're going to expect to see the load calculations. We're going to expect to understand that there's, are we providing natural or mechanical ventilation? And then how is this equipment going to meet those needs? And then how are we getting it to where it needs to be, right? Those are considerations we see. Depending on what version of the code we adopt, we may also be looking for additional efficiency packages, either in commercial or residential. But again, ultimately what I'm looking for is what's on the code, because plan review's done their job. Now I can go out in the field and say, okay, what's supposed to be here? And so when we really boil it down and we apply this concept of the mechanical provisions to a project, we're looking for four basic things: proper design and size of equipment, proper efficiency, proper distribution, proper controls. Like I said, we talked a little bit about this last week of plan review. When I was starting to develop this plan review field guide for us on how do we do plan review. It all starts off with equipment sizing and efficiency. Now the code tells us, now this is not the energy code, remember, this is the residential code, tells us we have to provide natural ventilation or mechanical ventilation. We have to make that choice. I was at the code hearings this past week down in Orlando, and this concept of natural ventilation is really under attack. As why are we even allowing people to naturally ventilate when in all reality it's not a consistent form of ventilation? It's not a permanent method of ventilation, right? There was a conversation, and then from that, there's also we get the idea that we have to require certain amounts of heating, right? That we should be able to meet that 68 degrees measured at 3 feet off the ground. Well, and that even too is something that was brought up, and at least at this point was sent away with some suggestions on how to correct it, because there are proponents pushing minimum cooling expectations of 80 to 80 degrees during the summer seasons. And so again, we understand that the code, the residential construction code and the mechanical code are telling us we need to have certain types of equipment to meet to make our buildings habitable, right? And so again, we see that in the IMC that we have to use the ASHRAE ACA standard 183 or an approved design to calculate that load. 1401 in the residential code tells us we're supposed to have a manual J to calculate the load and a manual S to calculate the size. So again, we're doing all of this math to calculate, or all of this expectation on the front end from the design and from plan review to say, what piece of equipment is expected in this building? Now, we talked about all that process last week, right? We talked about what is expected in mechanical code analysis. So if you have questions about that, we can go back and watch that video. We can talk about it at another time. Give me a call. I'd be love to just sit and talk about it. But when I'm inspecting a building, what am I looking for? I'm looking for those same four concepts that we look for in plan review: equipment size, equipment efficiency, ducts, and controls. So we're going to look at some examples and we're going to build on it from there. There's another pun for the week, right? We're going to build on these examples, right? If I've got a building, I know I've got a manual J. That manual J is going to have a manual S or manual D to show me how we're designing this system, how we're meeting the requirements. And again, that's whether we look at residential or commercial. We're looking at how does all this work together. And as an inspector, I want to know what is inside. One of the first things I need to know is what's inside the building thermal envelope. What am I inspecting, right? Where am I inspecting? Because I know my level of expectation for the duct system and the mechanical system that operates inside this conditioned space is going to be different than the mechanical system that operates in this unconditioned space. If I believe that this orange line represents my building thermal envelope and this green line represents just the wall, right, then I know this section here is outside the thermal envelope in a semi-conditioned space, right? This is like a loading area into a building. This would be similar to like a garage, right? If we were looking at it from a residential perspective. If we had the building, we have a garage. It's inside the wall. There's no rain, but it's still not part of the conditioned space necessarily. I have to know if it is or if it's not, right? Same concept, and I'm going to use a couple of big mechanical examples because they're a little bit easier to understand, or at least to visualize. So I would have this project here where it's a large storage facility. And when I go out to do the inspection of this storage facility or of this storage warehouse, I see there's a bunch of offices built in it. So I talked to the designer, talked to the contractor. Oh yeah, we decided we needed more office space, and we hadn't yet used. We knew we were building that warehouse building, so we're just going to throw some offices in it. Good, thanks for that. We need a plan. We need a revision then, because this is not part of the original plan, right? We were expecting a part storage facility with 35 people, right? It's got a couple fans to provide ventilation. It's got overhead doors that are going to be constantly open as you're moving parts in and out. So you had one heater, two heaters, I think. Two heaters originally designed for this building. That was it. It was a semi-heated space. Well, that changes when we start to add in offices. They're going to be fully occupied. So this shows 23 occupants. Well, that's on the first floor. Apparently, we decided to, in this design, go to 2 floors, right? And so again, we're in a design where we're adding extra mechanical equipment, but we need to evaluate what's going on. So when I'm inspecting it, I look at my equipment, and I see that I've got identified this gas unit heater, and then I've got all these condensing units on the outside, right? And some furnaces. So as I start to look at the building was originally designed to be just a big warehouse. And so it has a thermal envelope along the exterior wall of the building, right? Well, then I start to look at the actual design. And if we look in, we see office 1, office 2, corridor, first floor. We've got duct work going between the space, between the structural members, right? We've got some ducts going through there. Second floor, ducts in this open space at the top. Well, the question then becomes, what's the level of conditioning, right? We know this area is semi-heated. This area is fully conditioned. What is this wall going to do for me? Is a great question, right? Are we going to insulate this wall, both here and up here, to prevent air moisture condensation in and along these exposed ducts? These ducts are not insulated, right? If they're in an unconditioned space, they need to be insulated, right? That's what the code tells us, because we insulate ducts in order to resist condensation accumulation. And so I need to, again, verify, we zoom in there, these supply and return ducts need to be either fully insulated, or we need to verify the extent of that exterior wall, that interior separating wall, right? So again, that's going to affect how I do my inspection. What am I expecting to see? Right? As I go on site, I start to look up here in the top corner where I see the condensing units outside. I can follow with a penetration of that exterior wall into the building, and then I see it separating out into these diffusers, right? The duct looks like a very simple line, except that's just in drawing. What am I actually looking at when I get there is a different question. But again, I can start to identify, where are the pieces of equipment, how are they getting what I needed to get, what I need, where it needs to go. Same thing here. Again, we see that heating unit, we see the 3 ventilating fans, the 4th up here on the dock. Again, all of this is part of what separates out, or what we're looking for in a mechanical inspection. I'm looking at it from an energy perspective, saying, where are these pieces in relation to that building thermal envelope first and foremost, right? Let's look at another project. Again, it's, maybe not necessarily residential, but again, it shows a point. If I'm going to do an inspection on this dealership, which I'm sure we all have dealerships at some point that we've dealt with, or auto repair facilities, this building thermal envelope gives the impression that this entire building is one conditioned space. In reality, we know that's not the case. That's not true, right? We're going to have separation between our offices and our showrooms and our business operations piece area versus our service bays, right? The conditioning expectations are different than here. And again, we've got this paint booth that's going to have its own heating and cooling, and we have a spray bay, a wash bay. So as we start to go into these different areas, we can see that we've identified heating units in between that operate inside our wash bay. We've got our wall here, right? We've got our paint spray booth with a ventilating fan and some exhaust fans. We've got some heating units to, again, control the climate inside the area. But again, it's different and separate from our wash bay. We've got fans and heating units that exist inside our service bay, right? To provide both ventilation as well as we see in this little call out box here, some CO2 monitoring, right? We see controls that show how and when we exhaust based on levels of both gas calculation as well as hours of operation, right? We want to control the amount of air that goes into this and the amount of air movement in this area. So again, we're not treating all of the areas as the same. I need to evaluate each one differently based on their their requirements for ventilation, their mechanical needs, right? I'm looking at a couple heaters and some exhaust, a couple heaters and fans and some exhaust. And then when I look at the interior office space, now I get a little bit more complicated, right? Again, I'm expecting to see that this separating wall between the offices and the service area, which I think is actually is this part down here. This is the service area. Then I'm going to see that we're going to install different ducts, different materials in that design. This is one of those areas where I see this all the time come up, both in commercial and in residential, where we design a system based on a particular type of duct system, but we don't recognize alternatives from the beginning. And so that usually causes some stress, some frustration. And this is one of those things where, again, we like to make sure that people understand what is expected and where are the boundaries for an inspector to make decisions. As we can see in this plan here, they've laid out the basic layout of their mechanical duct systems, but they've given a reference to the builder that says, here are the different sizes and alternatives for ductwork that you can follow, right? So if you want to use a round duct, you can do a round duct here based on this much CFMs of air, you can use a 12-inch duct, right? If you want to use a square duct here, you can use this size duct. If you want to use a rectangular duct over here, go for it. This makes it a little bit easier for me as an inspector. And this is one of those things as a building and plans examiner, I'm looking for my inspectors. Because what I don't want is 15 phone calls where, they gave me a square duct on the plan, but they put a round duct in the building. Is that okay? Well, depends on what it is, how long it is, what kind of airflow we're trying to get. Because a 14 for 14 isn't going to, if I got a 14-inch duct that's a square and a 14-inch duct that's a round, they're not going to give you the same amount of air movement because they're different frictional differences, design differences. So again, I sometimes will get plans or usually get encouraged plans that show these ductwork design alternatives so that in the field we can say, this is the right duct, and you can have this alternative duct as an option. Without that kind of specification, it really makes the inspector the one responsible for that. And despite as much as I know many of our inspectors are not very knowledgeable, practical experience and all, when the lawyers call and say, why didn't this work? The person that gets blamed is the one who doesn't have the documentation, right? Well, I know this is the right size, but what was approved? What was designed? What was spec'd, right? So have this kind of thing is important to make sure we don't put ourselves in a position to get to create stress in a legal situation. But again, we see here where it identifies the ductwork installation schedule based on, again, location and what type of duct it is. So again, I'm looking at ducts and I'm going to have to identify, is this a supply run? Is it in a conditioned space? Well, then I know if it's a supply run in a conditioned space, it needs to have an R4. But if it's outdoor fresh air in an unconditioned space, it needs no duct, no insulation. right? So I can start to piece together what the expectations are when I'm in the field. And again, that's what I'm looking for as an inspector is how do I do my job and know what I'm supposed to be looking for. One of the things I use this picture because I just think it would be comical to bring up the point. One of the things we're doing in one of the things that the mechanical provisions of the energy code are saying is that if we have a mechanical room, we need to make sure it's thermally isolated from the rest of the building, right? That doesn't mean just spray foaming, right? We have to actually think about it a little bit further than that. There's other alternatives that we've seen. One that I've seen recently, talked about this week, is the use of control dampers that are based off of the mechanical equipment. This example here shows us a very simple basement, right, of a house that says, if I'm going to have my furnace in this room and it's bringing outdoor air in as part of the combustion process, that unconditioned air could impact the surrounding conditioned space. So I thermally isolate it, right? I seal it, I protect against thermal loss. One alternative would be if we said, okay, I'm going to bring it in, but when the furnace is off, there's going to be a damper that closes so we don't get air, uncontrolled air intake as part of that system. So again, maybe a direct vent or something like that can be a part of that. So again, we start to think about alternatives. Ultimately, what we're looking for is, again, how are we protecting against uncontrolled air infiltration? The same thing we talk about with our air barriers, right? It's all part of that same calculation, that same conversation. So we start thinking about mechanical rooms, think about how are we going to protect, what type of air do we have coming in, and how are we keeping that air from affecting the surrounding area? Because we thought about if it's 20 degrees outside and I'm trying to maintain 68 degrees inside, and this is just 20-degree air coming in all times, that's going to impact the surrounding area. I'm going to have to retemper, reheat all this air because of that overly cooled air. Or the opposite, if it's 110 outside, 110 degrees outside, and I'm trying to cool it, that's 60 degrees of extra heat coming in, extra humidity that I'm going to have to address that could create problems both inside the building and as part of those duct systems. So again, when we think about what that field guide is trying to do, we're trying to give some guidance on what should we be thinking about in our inspection process. Now, obviously, we've talked about mechanical sizing, but when I'm going on site, I need to make sure that what's on my details, what's on my plans is what I find in the building, right? If the plans tell me there's supposed to be an 85,000 BTU furnace, and I find 148,000 BTU furnace, even if it is the right efficiency, it's still not the right piece of equipment. So I need to verify what's the change. Are you installing 2 of them instead of 4 of them? 3 instead of 4? How is this going to impact my what is supposed to be in this building? Again, with our manual J calculations, our res check calculations, com check if we do that for multifamily. Again, we have designs. We need to verify that equipment is what we're finding in the field. If it says we're supposed to find a gas-fired 108,000 BTU system with air economizer, then that's what I need to find, right? Not, I found a piece of equipment and it's out there. Similarly, when we start thinking about the connection, the relationship between it, it's part of it's understanding where those controls are. If I've got a thermostat running an indoor heating unit, right, as part of a vestibule, then I need to make sure that they're properly connected, right? That we're independently controlling that vestibule separately from what we're doing with the rest of the building. So again, properly sizing. If I've done the work on the plan review side, this should be easy for my inspector. Find the piece of equipment, find the connecting piece for controls. Same thing when we start talking about domestic water heaters, right? If it shows up on our com check or our res check, then we're supposed to have a 119 gallon unit, and we show up and it's only a We got a 119 gallon unit here, but there's a 50 gallon unit as well. Wait a minute. I was expecting 1 unit, not 2. So what's going on? Verify what's on the plans, match what's in the building. Including considerations for hot water recirculation pumps or other controls like this. If we've got a building that's running, multiple facilities, we think about this maybe at the airport or at Buc-ee's or something of like that nature, right? Any one of our commercial buildings, we're going to have these hot water recirculation pumps to reduce the amount of downtime between our water systems being on and not being utilized, right? Sorry, I gotta drink some coffee there for a second. But again, when it's more than just identifying the right size, the right equipment, right? It's also identifying the right efficiency. Taking that extra 5 seconds to say, 5 minutes to say, yes, it's the right piece of equipment. Yes, it's probably seen it or probably set, probably connected. I don't see any leaks around the fuel systems, fuel lines, but it's also saying, well, I'm also supposed to have a 21 SEER system, and you've installed a 15. There's a problem there, right? It's not the right piece of equipment. You know how I like to keep life simple and usually parallel it back to my own experiences. When I bought my car, I wanted leather seats, right? If I showed up and they gave me cloth seats, I would not be happy. That's the same thing as buying a 21 SEER and getting a 15, right? I paid for a 21. I'm expecting a 21. And so that's where it's, again, part of this process of verifying what's in the building and what's in the plans is super critical. Because what's going to happen is when things don't work out right, it's going to come back to there was an efficiency or equipment change that's going to be the cause of some of the problems that we face. And again, that efficiency might be affecting or impacting things like air balancing or combustion air calculations, right? So there are going to be controls that come into place or come into play when we start talking about these systems and what's being done, not only to keep it space conditioned, but to probably ventilate and maintain air quality within a building. Now, one thing I think is important to point out is going to be the fuel source sizing that we sometimes see. Now, remember the fuel gas code tells us that when we identify buildings, we build buildings, we picked certain types of equipment, and we base the fuel lines, the fuel source piping, off of those pieces of equipment, right? So we've calculated that at the beginning of a project. One of the things I see all the time is when we update, modernize, change out equipment, we impact more than just that one piece of equipment. Here's a very simple example. We've got earlier this week I was in a meeting where we were talking about, well, where do we need to make the changes? Do we just add bigger lines out in the road? We'll be fine. It's not always what's in the road; it's what's in the building that we need to think about, right? What you're getting to the house to the regulator is probably more than enough when it comes to gas to do what you need to do. The question is the regulator, and then also what comes after it, right? So if I'm building a building and I've designed a building, I've got a house, I've got a range, a furnace, and a water heater, and then I decide that I'm going to upgrade either during construction or 5 years after construction from a traditional 40-gallon tank to an instantaneous on-demand water heating system. I'm going to install that new piece of equipment, and I want to make sure I update and consider all of the impacts. It's not just to take it out and put it in, right? Because we're going from a 45,000 BTU system to a 200,000 BTU system. I've seen some go as high as almost 400,000 BTU for an on-demand water heater. That is going to impact the size of all of the piping that leads to it. So all of this piping will need to be changed to compensate for this new demand, right? And so it's not a simple, and that's one of the things I think is when we think about, construction, we think about mechanical systems. Sometimes we see the change out and we think, okay, they're just changing one to the other. Oh, it's going to be more efficient. It's not about efficient. It's about safe, right? And so if I'm tripling the size, quadrupling the size of the load, the drain on that system, then is my regulator going to be properly sized, or any of my pipes to be sized, right? And I'm going to run those pipes or replace all of those pipes in order to accommodate that. So again, those are things that we're thinking about when we think about, it's not just a question of, is it the right efficiency? Is it the right size? But again, how are we fueling it, right? Those are considerations and things that we in the field need to be looking for, especially when we talk about replacements. Let's talk a little bit about the ducts and distribution systems. Now, whether we look in the fuel gas code, where we talk about the different types of materials, terminations, extensions, and those kinds of things that we find in the code, or we look at the mechanical code, right? Fuel gas or mechanical, they both provide us, as well as what we see in the energy code. I'm not even going to use energy code sections on this section right now. We're talking about fuel gas IMC mechanical code tells us that we need to size our equipment and our ducts based off of, if you look at what 603.2 says, we're basing single dwelling units off the manual D. We're basing everything else in the commercial design off the ASHRAE Book of Fundamentals or other calculations, right? We need to properly size. If we were to go back to the energy code, the energy code tells us we need to make sure that we size it based off the manual D. But it's not the first and only place that tells us that, right? The mechanical code tells us that. The residential code tells us we need to size the equipment, to size the duct distribution system to meet the demands of the building, to get us the air where we want it, right? So we take that air handler and we can say, move this air through the ducts and through the plenums, through the different duct systems to the rooms where we want them. Again, whether that's residential or commercial, it's the same concept, right? Combustion air ducts have to be installed to handle the load, to handle the volume of air going through it. And we also think about how we seal those as well. So one of the things I see all the time, and one of the questions or one of the comments as a plans examiner I'm always putting in when it comes to mechanical designs is a lot of times I'll see the design, I'll see the layout, but I don't see the details that my inspectors need, right? I'm going to jump ahead a square, right? So when a project is being designed, whether that's the architect or the mechanical design professional is drawing out and saying, okay, I need this much air at this location based on size and everything else, right? I need this much air. I need this much air, these different locations. He's putting all that information into a computer. He's determining what type of material we're going to be using, whether it's a flex duct, whether it's going to be a round duct, all these different expectations are being part of that calculation. That's the sizing that takes place, that manual J, manual D, manual S software component, right? It's telling us the size of the coils, the size of the ducts. So that design ultimately we get or should get in our manual J, S, and D calculations. This should be something we see, right? But what we're seeing here are some weird shapes. I'm assuming these are flex ducts. I'm not sure what these little triangles are. I got squares once in a while, triangles. Go to this design, I've got some letters. I got a 4AD, 4AD, 4AD. Over here, I've got a 4AD. I've got some 2J2s and a 2J3. Right? Those concepts, those images don't mean anything to me. What I need is for my inspector is a detailed sheet that says what each one of those are, what each connection looks like, right? If you're telling me what a 2J2 is, then put it down on a piece of paper so that when he gets on site, he knows exactly what kind of connection he's looking for. When he sees that diffuser, he knows what it's supposed to look like. When he sees that air handling system, he knows what it's supposed to be. Not that there just is one or that it's all properly connected, but that he's got the right information. Is this a 45 or 90 degree? Is this a ridged or a non-ridged, right? All of those different components can impact how air moves, right? When we start thinking about, even if we did a very simple design for air distribution system, from a simple mechanical room to 4 rooms in a building. We send a run down, a main trunk down, and do runs off each side. Sounds simple, but it still means that there has to be air moving through that building, right? That's when we get into the mechanical design. It's going to be the method of air velocity calculation is monitoring how much air moves through to make sure that we have the right amount of velocity at the beginning to get the right amount of airflow at the end, right? And we may be choosing different connections because of the amount of friction that it creates, right? And so again, these are things that we have to think about in the design. And then when my inspector gets on the field, he's not doing this math. He's not thinking about these. He needs to be looking at a diagram and saying, okay, here's my trunk, and then here's where I'm making a run off of it. What type of run? What type of connection? What type of elbow are we using? That's a great question that he should have to think about. It should be provided to him. And that's, again, a function of the relationship between plan review and inspection. Because part of what he's going to be looking at is this duct insulated or not? Is it inside the thermal envelope or not? Right? You know, we've got insulation inside around these ducts. We've got some that are not. We've got no insulation here. Well, that we can make certain assumptions about the location of the air barrier of the thermal envelope based off of what we're seeing in those duct designs. And sometimes we see that, and it could be related to more than just moisture accumulation. There may be a variety of reasons why we require ducting to be insulated. But again, when we think about it from a perspective of an inspector, I need to know what's going on and where it's at so that I can go up, do my inspection, and get out of there and not spend 3 days trying to figure out, is this the right equipment at the right locations, right? Have that information available and have it all on the details that are part of the design. Because he's looking also at, we're looking also at how we're probably sealing these duct systems. Because during that ref inspection, we should be able to have that duct blaster test, that duct testing, air leakage testing, to say, is this duct actually providing the air where it's supposed to? Is this a consistent system, or do I have air leakage because you cut a hole that nobody knew about? I was doing a project. We were doing a project over in Hobbs last year. We went and did some inspections with them. And when we found out was someone had done some work very similar to what we see in this diagram here. And when they did a replacement, excuse me, and didn't replace the sheet metal. So there was a 3-foot hole in the trunk of this HVAC system. And the guy was saying, well, it never really got quite cold enough ever again. But, you know, I trusted them. They did it right. Well, they did what they had told you they were going to do, but they didn't reseal it. They had sent, I don't know what happened. Don't know. Don't need to know. But again, what happened is, again, he had a hole in his trunk. And he was losing all his air to his basement, to his crawl space. Not a basement, it was just crawl space. So again, once they reinstalled that, completed that hole, he was able to get a lot more air through the building, and he was able to control the environment and didn't need the upgrade that he thought he was going to need, because it wasn't an equipment failure, it was a distribution failure. Same thing when we start talking about how we seal, right? We start sealing these to, you know, we see here the installation of some spray foam But then we see this bat insulation. So when I asked the contractor what was going on, well, I just figured we needed an extra insulation around it. This again becomes the conversation we have all the time with, is it the right type of sealing, the right type of insulation for the right application? And the answer is no, not in this situation. Stuffing bad insulation like this is not going to give it the thermal resistance qualities that we need out of a building component, right? If I'm sealing it, you're sealing it just as well with this spray foam against air intrusion or against fire blocking and air and draft stopping than you are against that's more the interest than it is the thermal insulation, right? Because remember, we're not trying to heat the air inside this through insulation. We're trying to resist moisture accumulation along the exterior sides of the building, of the component, right? We need to make sure we're also, again, this to me does not look liberally applied. This looks like, someone's like cheaping out on me on the peanut butter and jelly right there, right? If you're gonna apply a coating to a seal, then again, apply it like it's peanut butter, right? Just big and thick on there. But remember, not every system that uses forced air, thermal ducting system. So again, we might have pipes, we might have hydraulic systems or radiant floor systems. So again, evaluating what type of insulation is needed, where it's needed, and how we're protecting it is going to be, again, part of that process. Because we're not only protecting it against damage from the environment, but also damage from other contractors, right? There's a couple things going on in this picture that I'm not really sure what happened. All I know is it looks like the plumbing guy got there before the framers finished. And so they showed them who's going to win. And in the end, nobody wins, right? But again, we want to make sure that we're thinking about how these buildings are going to be designed. And this is one of those reasons why I don't do many of my rough-in inspections until all the trades are done. Because it's usually my experience that if I do rough-in early, then somebody comes in and pokes a hole through something I didn't want them to poke a hole through, right? Or cuts a line that we thought was actually going to be good. So again, think about how we design them. And one of the things we're seeing more and more in the design side of it is the use of technology to do 3D imaging of systems, right? How do I load in a duct system here when I've got all this plumbing and piping and everything else going on? So again, thinking about the layout is going to be critical because that's a part of what we as inspectors look for. I'm looking for a simple way to get in and out of this inspection and how I'm going to protect against, again, draft stops and fire blocking to prevent air movement or fire movement through assemblies, right? And that penetration protection isn't just for the fire service, it's also for us as part of that thermal envelope protection. I've seen several projects where, again, the contractors cut a hole that's too big, similar to what we see in this image here, just slightly too big. Now we need to make sure we have a process for resealing it that allows for actual control of air, not an attempt at controlling for air movement. And then again, we see here, we've taken some time, we've sprayed the sealant, and then we cut some additional holes because we wanted to run a couple more electric lines through it, or maybe it looks like maybe a phone line or something, right? And so now we've got to seal these areas. Now, I'm not going to tell you that does not look like a good insulation job. That's none of my business. We're not looking at that right now. We're looking at the mechanical side of it and saying, hey, what were we installing? And how did these pipings and how did all this work together, to prevent, again, clogs and constrained air movement in our exhaust systems. So again, we've talked about the mechanical equipment, we've talked about the efficiency, we've talked about the ducts, the distribution. Now we talk about the controls, right? Because it's all about control. And so whether we see those in the requirement to install these thermostats, or like in this example from this townhouse unit, We've talked about this. I think last week we talked about, we see indoor fan coils identified. We see exhaust fans identified in the design, right? So this is a outdoor condensing unit going to a bunch of mini splits in each room. This is, let me get this right. First floor, second floor, top floor, 1, 2, 3. And so again, we have the exhaust, we have a unit, but what we want to make sure is that we have controls, not just that we have the units, but that we have controls installed, right? The thermostat to be located in the zone it controls. And so we see on the first floor a thermostat associated with the system. We go to the second floor, we see a thermostat controlling this zone, this grand, I think this says great room, kitchen area. Then we go to the third floor, or the second floor, whatever you want to call it, where we've got 2 bedrooms, each with their own unit, each with their own thermostat. Main bedroom, thermostat. So again, we're looking for those controls, and that's part of the process, is making sure where are they required, what are they doing the right thing. Remember, just because they're capable of doing certain things doesn't mean that the client's going to use them. But more importantly, we need to make sure that the controls are there so they'll be able to have that level of control. Some additional things to think about, again, is when we're looking at some of those water heating systems, again, I always like to remind us to look out for those heat traps to prevent over tempering or overuse of the impact of water sitting in that tube long enough. The cold water will seep back into the holding tank and then require us to reheat this tank. Whereas if they install, the code identifies in 2020, I think it's 2018, it started to identify the heat trap in the commercial, comes up in the residential in the 21 for having this heat trap to prevent uncontrolled water movement back into the heated tank and then causing that tank to have to be reheated over and over. And then again, those of you that have pools, that might have heated pools, there are some expectations there. So if we're doing mechanical systems associated with those, making sure we have the appropriate controls in place, or the appropriate, if we're not going to have controls, then we're applying some type of on-site renewable energy. So most people just go with controls because it's easier than having a bunch of heating panels. And then again, they can have an impact on how, again, that air leakage expectations in our buildings. So I know we went through that kind of fast. I don't see a whole lot of questions online, but if there's questions, obviously you can raise your hands, let me know. We're going to talk about compliance paths next week, as well as our interior lighting. And then you'll have a chance for your bring your questions and have some time with the experts from the team. And then we'll get back into energy plan review for lighting, power, and plumbing systems. For those of you that might be interested, there is a training next week on Tuesday with the BAT and continuous insulation manufacturing experts to talk about the different methods of installation. So if you know contractors that have questions, or if you have questions about BAT insulation or continuous insulation, this might be a good 2 hours to sit down and talk about that. Excuse me. Remember to use your survey if there are topics that you think are going to be useful. We are going to, in July, I think, restart the plan review and inspection series, but it's going to be set on different dates or a different time frame or different schedule. So again, that'll be something that we'll just keep renewing so that if you have questions, you can always jump into those conversations. Excuse me. Sorry about that, guys. Then when if you haven't already checked out our website, again, that's where you can find some of the different technical resources and documents. Feel free to always reach out to us at the TX helpline at shumscoda.com with any questions, or to give that information to the to a contractor that might have a question, or design professional. We're always here to help, and be more than willing to reach out to them and help them along in gaining code compliance. So you guys have a great week. Be careful, be safe, and again, I will see you. I won't see you next week, but I'll see you again soon. So you guys have a great week.